Well, hey guys, welcome back to the shop. Thanks for being here. So in the last episode of this hog splitter chopper thingy that we're forging, you got the Damascus or pattern welded steel finally forged and just started to thin out an area for the blade. So I have it forged down to about 1/2 inch thick, but I want to make sure that I still have enough thickness after I put in my ladder pattern to forge the thickness of the blade that I want. Now the original intended design on this blade was to be a 1/4 inch thick at the spine, which is not, which is a little thinner than an actual hog splitter probably would be. But as I mentioned in the last video, this is actually going to be used as a hatchet or brush machete, that kind of thing, like a heavy machete, I guess would be probably the most accurate description of the intended use for this particular blade. And it resembles a hog splitter in design for sure, and could be used as that too, but it's the design is going to be slightly modified. So I want to make sure I have enough thickness, and here I have about 1/4 inch thick, but that's after I forge everything out and before I do any grinding. And so I wanted to start with a little more thickness if I could. So I went ahead and decided that was going to be the handle end of the tool instead of the blade. So I went ahead and forged that down flat and or narrower into what's going to be the handle. This is going to be a twine wrapped handle with fiberglass resin. So that'll be the handle construction on this. So I need to forge out an entire handle. It has to be thick and stiff enough without any additional stiffening qualities of like handle scales or anything like that. So I'm taking that into consideration. But I also, and so how thick do you make it? You know, when you're first forging the handle out here, or when I was doing this, I wanted, I felt like I want to leave it about, 3/8 of an inch thick by 1.25 inches at least. But that's quite a lot of steel, and also keeping in mind how much steel do we have here to work with. Can we get the dimensions that we want here? Can I get the dimensions I want? And then also, just a practical application, how heavy is this thing going to be when we're done with it? So pretty quickly I was hoping that I had enough steel here to get the dimensions that my client requested. And I guess worst case scenario here is I forge out a blade that's not quite what he wants and I have to start over again. And that's the reality of the custom knife business. You're doing something you haven't done quite before. You haven't done something quite like this before. All the skills involved to do this are there, but if you've never done an exact project before, there's a chance that you will have to start over at some point in the game. Hopefully that's not the case here. So we're working on forging out the blade now. I've started on the handle, and basically, since I don't know exactly how much material I need for the blade and how much material I need for the handle, I'm sort of working my way to the middle. So I'm starting at both ends. In worst case scenario here, I'm just gonna end up with a blade or a handle that's not as long as my client wants, which means I will finish this one out and sell it and make him what he wants. I at this point I understand that if I had not added that extra steel to my billet like I did in the beginning, I would not have enough steel, and I feel like I'm going to be cutting it close right now. So I've gone ahead and started to put the pattern into the blade and forge it out, and then just work my way back. So the ladder pattern here is created by cutting grooves into the billet and then forging that flat, which reveals the sides of the groove on a 2D dimension or 2D scape, if you will. That's how that's done. So I'm just forging it down to probably about 5/8 thick, putting my grooves in, and then forging it down to closer to the finished dimensions. Still, we still need to have some to grind off and clean the blade up, and that kind of thing. So working with sort of an unknown quantity here, and trying to get what we need. There's probably a way to calculate the exact volume of steel that you need, but a lot of aspects to a project like this have more to do with experience and relying on just how things work. And like I said, I've never made this exact project before, and so there are some unknowns here, and that's just the nature of the project anytime you do something you've never done before. So bringing you guys along here, this is not meant to be how exactly to do this the best possible way. Instead, this is we'll embark on this journey together, and we'll both learn, and you guys hopefully can avoid some of the mistakes that I've already made. So we're forging this out here using my 8-pound hammer, which is really too heavy, but the 4-pound hammer just it moves the steel, but not as fast as I would like. This is where a power hammer would probably come in handy, but combination of hand hammers and the press, we're getting the job done here. So I had somebody comment on the first installment of this video that saying I shouldn't make YouTube videos until I knew what I was doing or something like that. Or do you think it's a good idea to make a video while you're still learning how to forge? And I said, go away. Not really. No, I responded. I said, yeah, I do think it's a good idea, because the whole point here is so that you guys don't make some of the same mistakes that I've made. And secondly, I'm always learning, because I try stuff that I haven't exactly done before. Like I've forged before, but I've never forged this before. So anyway, maybe it was a waste of time to even respond, but sometimes you just wonder. Anyway, so forging out the handle blade transition here, and getting this handle moved over to the top side of the blade, and it worked pretty decent to clamp it in the vise with the spine, or the back of the tang resting against the vise screw there, so that it doesn't just keep rotating in the vise. And little by little forging this out. So basically what I was doing through this whole process right here is like kind of gauging how much steel I had left for the handle, and seeing how thin it was getting, and what kind of stiffness and wielding qualities that gave me. And it was kind of like this whole process was like, yeah, okay, I'll go a little bit more. We'll forge a little bit more here, and sort of continuing to gauge, is that too thin? No, that seems pretty decent still. We'll go a little bit further, until I got my 18 inches of handle that it's supposed to have on this project. So this here, forging out this little round bit, I'm going to put a hole in the middle here, and as I mentioned a minute ago, this handle is going to be hemp twine or something similar, wrapped handle with resin, so it'll be a durable, waterproof, etc. But anyway, that'll all be wrapped, so it'll be a nice little ring deal that'll help you keep your grip whilst using this tool. So now that the handle length is established, and we do have enough steel for that, here I'm getting my blade length here, which is 16 inches. So again, per client request, the blade's a little longer, I think, than a typical hog splitter. But again, this isn't going to be used for splitting hogs. So I'm forging in a bit of a tip here, a very abbreviated sort of clip point to it, just to add a little character to the blade here. And it's just roughed in there. There you have it. So you can see I have the blade is sort of curved the wrong way yet, and that's on purpose. And then the handle sort of curves as well, and you'll see the finished design here in a minute. But we're forging out the bevels now on the blade here, spreading that out, getting more blade width, and refining the tip there a little bit more as we go forward as well, and working in the bevels a little bit. So I had just enough steel to do what I needed to do or wanted to do on the dimensions here, and I'm hoping I have enough to grind the bevels in like I want to, get everything nice and clean without getting too thin here. Yeah, I mean, I guess there's always a possibility that something else will go wrong here on this build. This has been kind of a challenge, and it's the kind of thing here that it's one thing to make a video on something that you've made dozens or hundreds of, and even then, things don't necessarily go exactly like you want. But then it's another thing to make a video on something that you've never forged something exactly, like this. I've made swords. I've made lots and lots of knives. I've made big knives. I've made choppers. But I haven't made this, and this is different enough that there's enough different aspects here that, and then just sometimes stuff just doesn't go your way, no matter what. So normalizing the blade here, obviously, a very important part of the process, which gives you a homogeneous grain size, so your grains are the same size throughout the piece of steel, which is really important, and then relieving the stress that you create in the steel during the forging process, and especially when you're this is always necessary, but if it could possibly be more necessary, when you have a pattern welded steel with at least two different alloys combined, it's even that much more crucial. It's got a nice even heat on there, and the big forge definitely helps with that. You still can't just stick it in the forge and leave it, obviously. You have to move it a lot to get that even heat. And there's our quench. So I normalized it 3 times, and quenching it in Parks 50, of course. And this is more difficult to do in a forge, of course, but it's keeping an even heat on the steel for a little bit of time to make sure that it's up to heat. And I will mention in this case, with the 1045 steel being below the eutectoid point, anytime you go above or below the eutectoid point, technically you need a little bit of a soak time, or secondarily, and not preferable, a little higher austenite temperature. And that's because anytime you have more than enough, or sort of less than enough, if you will, carbon in the solution. And I should digress and mention that depends also on how much carbon you're trying to put into solution. So just because you have a hypereutectoid steel doesn't necessarily mean you're trying to put all that carbon into solution. But to the point of 1045, you have less carbon to go around in the iron, and so it's very much like butter scraped over too much bread, and you have to get that carbon evenly distributed, and that takes a little more time and or a little bit higher temperature instead of something like 1080, which is just right there. And once you're up to temperature, there you are. Anyway, nice and hard. Nothing wrong there at all. And shine up the blade a little bit on the grinder so we can go ahead and temper this. And my preferred method is to use my torch here, because I can put the heat exactly where I want it. And this puts off enough heat to do a good job of tempering, except for when my oxygen runs out. And I guess I should keep an eye on the gauge that tells you how much pressure you have left in the bottle, but I didn't. And so now I'm left with using the forge, which is a much less precise method. It can be done, but it is rather difficult to put heat where you need it. And so I got the blade tempered, but not to my satisfaction. Why don't you just get another bottle of oxygen? You say, well, you have to have a subscription or a lease with the company, which requires an application. Something I'm not used to. Anyway, there's the, and so that takes about a week. Anyway, there's the finished product, and you can see I had a little bit too much blue towards the edge there for my liking, especially with this particular combination of alloys. So I've re-quenched the blade here, and we're trying again. I went out and got myself a small propane torch. Not ideal, it doesn't put off quite enough heat, but it will work. And if you're working with anything smaller than this blade, or of less mass, shouldn't have any problems. You have to just kind of work it by sections, I found. And keeping my heat from running too much where I don't want it. A wet rag can be a technique. You saw me rather ineffectively, I should say, using the spray bottle a minute ago. So we ended up with a good consistent edge temper here, light brownish. And I will come back later and temper out the spine more after we've etched and done all of that. So this is as far as I got this week, guys. I would have liked to go a little bit further, but as usual, of course, I'm working on other customer projects and builds. So this is just a small part. But anyway, I appreciate you guys being here. As always, I'll be back next Friday with another video. Stay tuned, and we'll see you then.